Welcome to lecture number 16. Today we're going to talk about local extrema, local maxes and mins, and here's the definition. So a function has a local max at a point if that point is the highest point or has a function output that's greater than all points next to it. So if this is my p naught, then all p that are near p naught have outputs that are lower than the output of p naught. And this reverses, the inequality reverses when it's a local min. Okay, so an observation about local maxes and local mins, and this is relating that definition to the gradient. So if we're at a local max or a local min, the gradient is going to be 0. And the reason it's 0 is because the gradient always points to a higher function output, and there's no higher function output, so it's not going to point anywhere, and the only way to not point anywhere is to be 0. So if we were over here at this p, then it would point this direction, indicating that we should go towards p naught, and if we're at this p, it would point this direction, indicating that we would go toward the p naught. But once I'm here, I don't go away from that because that's the highest function output. And that's true for local mins too, and you can justify that using the negative gradient. Points where the gradient is 0 are called critical points. So we'll be referring to these points. And not all places where the gradient is 0 are local maxes and mins, but if you have a local max and min, then the gradient is 0. So these are candidates. Places where the gradient is 0 are candidate points for local max and local min. So let's do a quick example. Let's look at this function. So let f be x cubed plus y cubed minus 6 y squared minus 3x plus 9. And let's find the critical points. Okay, so we want to find the places where the gradient is 0. And once again, these may be local maxes and mins, or they could be something else, like a saddle point. So first off, we take the gradient, and that's going to be 3x squared minus 3 is the x component, and then 3y squared minus 12y is the y component. And this is going to be 0, so this implies that each of these pieces is 0. And I'm going to factor this piece. So this is 3x minus 1, x plus 1 equals 0. So that implies that x is 1 or negative 1. And then if I look at the second piece, the second component, if I factor out 3y, I'll get y minus 4. And that equals 0 implies y equals 0 or 4. And so we have 4 points, 4 critical points corresponding to these different x's and y's. So we'll have x coordinate 1, y coordinate 0, x coordinate 1, y coordinate 4, x coordinate negative 1, y coordinate 0, and x coordinate negative 1, y coordinate 4. So those are our critical points. At these 4 points, the gradient is 0. We don't know which one's a max, which one's a min. We could use a graph, but we'll see in the next section that we can use something called the second derivative test to classify these points.